So when talking about, again, I'll repeat a couple of things about that I already talked about. There are many different ways that we can classify your data, right? So when classifying data, we need to bear in mind that usually we have most of the time at least two dimensions and everywhere one category, right? Can anybody remind me what a category stands for and what a dimension stands for, or what a dimension mean? Any thoughts, any comments about that?
Yeah, the dimension is like the field in a pivot table in Excel,
There you
like a
go.
column. Yeah.
Exactly. A dimension is nothing but the something that we use to measure something, right? But can anybody give me an example of a dimension?
Yeah, we talk about a three-dimensional model, and you show us how is that we could view different like quarters. I mean, like fields.
And based on the examples that you have used so far, what would be an example of a dimension? Or
Region.
region? There you go. Beautiful. What else?
For example, on last class would be the GPA.
GPA. Amazing. With GPA, we established thresholds, right? So GPA was nothing but a measure. But we say, okay, for something that is acceptable, we have something below, something in the middle, and something above, right? So a GPA could be like between 2 and 3, could be something low. Between 3 and 4 could be something in the middle, and 4 and 5 can be something above, right? Which is something acceptable for giving an a threshold or giving a category. Exactly. I mean, either you can use dimensions such as customer, customer name, or customer location, can be region, can be um, um, another hierarchy such as an account, or maybe cost, well, customer already mentioned, or maybe country. Country can be another category, and so on and so forth. So actually, we use many different categories to try to segregate our data and understand what is the weight or what's the density for each one of the categories, right? So in K nearest neighbors, K stands for a number. So in other words, nearest neighbors, we can have 1, 2, 3, 4, and 5 or more groups depending upon your business, right? For instance, let's say that you would like to classify your customers. For instance, let me ask someone. Federico, do you work with customers? Federico?
Yes.
Okay.
Yes, sorry. Yes.
No worries. How can you classify them? I mean,
Um,
or in your business, how would you classify your customers?
I classify them by region
By region.
or by
Okay.
technology.
Oh, by technology. Can you please give me an example of a technology?
Well, for example, I'm a security consultant, so maybe
Mhm.
firewalls.
Oh, beautiful.
Uh,
So depending upon
yeah,
how complex the firewalls can be, right, is how
right.
you classify your customers. Am I right?
Yes.
Wonderful. Thank you, Mario. I'm sorry. Thank you. Gerardo,
No problem.
I'm sorry. And I was thinking about the next person to ask for. Gerardo, how, based on your business, how would you classify your, for instance, your suppliers?
Talking about my suppliers, we have raw materials, packaging
Raw
materials,
packaging
APIs.
materials.
Yes,
I'm sorry. What was the last one? KPIs
uh,
or APIs?
APIs,
APIs. Okay.
principal active ingredient. I believe is the meaning of these acronyms.
Oh, okay. Interesting. And so depending upon, so you have different categories depending upon your suppliers, right?
Yes,
And Wonderful. So any other example of categories that you may use for, or let me rephrase that. So based on your business, how powerful or how interesting would it be to classify the different areas within your business? Or what would be an example? Maybe Ibera. Let me give you an example. Give me an example about within your business. Oh, sorry, someone else, right? It was was about to give an example. Go for it.
If I can
Fernando?
share
Mhm.
with you some interesting fact in
Beautiful.
pharmaceutical companies,
Mm-hmm.
this classification is used for determining which sanitary authority regulates the drugs that we manufacture here to export to many countries. So this classification has relevance because
Mm-hmm.
the regulation that applies to the different countries that we export to.
So, for instance, you have sanitary entities that actually, depending upon the source, or oh, I'm sorry, depending upon the nature, maybe the country, maybe, for instance, the US perhaps is the most strict sanitary regulation entity, right? Or maybe
Yes.
there may be more. So depending upon the sanitary entity, is actually how you can classify the drugs or the medicines, right? That you
Yes.
can and how you classify them based on export or import. Am I right?
Yes.
Wonderful. So exactly, depending upon the business, there may be different entities or different ways to classify your data, right? So nearest neighbors would help you to, for instance, if you don't have in mind, or better said, as per being a classification method, let's say that you say that you have, for giving an example, 10 groups. You would like to classify your data based on 10 groups, and you would like to understand what are the 10 groups about, or maybe you have in mind what are the thresholds, and you establish what are the groups about, and you would like to classify your data based on those groups. It can be either thresholds. A threshold is nothing but the limits that you establish for the first group. Let's say between 0 and 10 would be the first group. 10 and 20, 20 and 30, 30 and 40, 40 and 50, 50 and 60, and so on and so forth, right? So there until 100, it would be 10 groups. But what if you think that a group would be something different? You have a category that it would be kind of customer one, customer two, customer three, and so on and so forth until n number of customers. And you bear in mind that you would like to classify your transactions, or you would like to classify your products, or you would like to classify your revenue, and so on and so forth, depending upon where are you, I don't know, delivering your product, or where are you getting your product from, right? So in other words, you need to bear in mind what are the limits for your groups. What are your limits for your products? What are your limits for your transactions? What are your limits for your entities, and so on and so forth. So once that you bear in mind how many groups, or what are the name of the groups or the categories, you can use this nearest neighbors training set in order to understand how's your training data working. Okay, let's get it started. Okay. Nearest neighbors, pretty much, I mean, as any, if you remember, when we use logistic regression, first we train our data set no matter how much or how much data or how many transactions we had, we train our data set. Do you remember what was the maximum limit for a training set?
40%?
40%, there you go. So no matter whether we had 10 records, 100 records, 1,000,000 records, 10 million records, 100 million records, and so on and so forth, we only use at most 40% to train your data. So in other words, to train means, okay, what if I tell Rafael Gomez, okay, if I want to give you an example of something, I won't tell you all the scenarios, only give you what is the logic what are the rules or what are the thresholds. To give you an example, right? So when you want to teach someone to do something, you don't give all the scenarios because it would take you like a lifetime to teach someone all the scenarios, right?
Right.
So for instance, in your kind of business, if you want to give examples or train someone, what approaches would you use or what examples would you use in order to give them an idea, in every word, push them to try to figure out the things by their own?
Well, if it's in my field, I take
Mhm.
them to the jobs, to the projects, in the way that they understand exactly what we are doing. I mean, we are building many things, many infrastructure things. So
Mhm.
I think it's the best way that they understand and realize what we are doing and the complex of each activity. Because, as you know, every project has a lot of activities related. So I think
Exactly.
that's the best way.
So, and by projects, do you mean, you mentioned infrastructure projects? Does it mean, do you work in construction or what kind of infrastructure projects do you work on?
Yeah, it's construction.
Construction. Let me give you an example. So you can think of, when you talk about construction projects, you may think of a building, right? Like too many floors, or you may think of a house, or you may think of what else aside of a building or a house, what
No.
other infrastructure project you can work on?
No, the type of project is water treatment plants,
Oh,
pipeline,
water treatment,
yeah,
water treatment.
water and
Mhm.
roads.
Mhm.
But our experience is more in water right now.
Oh, wonderful. Now I understand what we're talking about. So when we're talking about water projects, you may think of how to store the water, right? And depends upon whether it comes from, depending upon the source, right, of the water. It's the type of building or the type of infrastructure that you're planning to build. Correct? Am I right?
Yes, you're right.
So, what are the different categories of infrastructure that you may build in order to contain water or in order to manage the water? Categories. Think about
Well,
categories.
water right now, and we are working with trains, rails and trains right now.
Oh, wow.
So, you know, this Tren Maya and of the last projects the last government or administration starts. So right now, I can say that maybe on my field, we have these two levels or areas, water and trains.
Oh, wow. So,
And it's just
but
two areas, but there is a lot of things. I mean, it's
yeah,
it's very wide.
so so heterogeneous, right? It's not
Right.
homogeneous to say, like for instance, because when you said construction, at the beginning I thought about buildings or houses, right? Nevertheless, you mentioned something wider. So what it means is that you may have more than 2, 3, 4, 5, or 10 categories, right?
Yep.
How many kind of construction projects, heterogeneously speaking, would you manage? 10, 20, 30? How many?
10 maybe.
10. 10. Okay. And what would be the difference between, let's say, the lowest level project or the highest level? Would it
It's about
be
budget.
budget?
Everything
There
is
you
about
go.
budget.
Budget. And revenue? Can we talk about revenue also? Because as more money you invest, is as more money you are expecting in return. Am I right?
Well, yeah, but we expect that we will have revenue of all the project, but sometimes it's harder. It depends. So right now, we select the projects with the budgets. I mean, we take projects for 500 million to that's
500 million.
the less amount that maybe we can consider to be part of.
Okay.
And well, we don't have a top right now. We're having projects. We have a backlog of 30 30,000 million right now.
Wow. So that means that you say 30,000 million is
Yeah.
what you said. Okay. So what it means that out of those 30,000 millions is that you can classify them, those 30,000, into separate projects, right? Some of them maybe 1 million, some others maybe 5 million, some others maybe 10 million, some others maybe something else, correct?
Correct.
So you can establish your thresholds. So depending upon, let's imagine that you are establishing the threshold based on every 500 million, right?
Yep.
So in other words, you can establish 3, 5, 4 groups between 0 and 500 million, between 500 million and 10 million, 500 million and 10 million, 10 and so on and so forth, right? So you can establish, depending upon the weight of how much you need to invest in your company and how much you're expecting in return, you can create different groups or thresholds. So between 0 and 5 would be one group. Between 5 and 10 can be second group. Between 10 and 15 would be a third group. Between and so on and so forth, right? Until 30, we can say, well, we have 6 groups, right? Divided by 5 million each group. So in other words, with KNN, we first imagine how many groups we are planning to kind of segregate our investments. And this algorithm will help us to, based on those ideas that we have, just establish the number of groups, and the algorithm itself will create the classifications based on the number of groups that we create. So in other words, let me go. So for instance, here, it takes into account, actually, I think the presentation sometimes is not that helpful. So let me use my powerful PowerPoint skill. I'm sorry, my powerful paintbrush skills. So I think this is the skill that actually has given me kind of more work. But let's imagine this, that we have our limits, right? Which would be nothing but taking into account that the least amount that we can think of is 0, correct? $0. You are investing $0. However, what if we establish the thresholds between 0 and $5,000? Also here, it would be $5,000, right? So he will be 5K, $5,000. Here we can be projects where we are investing $10,000, right? So let's say that. So we establish the other threshold here, which would be $10,000. Why not? Why not, right? $10,000. And so on and so forth, right? $20,000, $30,000, and so on and so forth. So pretty much we're establishing the thresholds for our investments, right? So depending upon, and same for the return of investment, or you may think of any other dimension. So aside of investment, when you are performing projects, for instance, Rafael, or let me pick up someone else, right? Because there's nothing biased. Samuel. So aside of investment, what other dimension you may think of in order to classify your investments aside of investment itself? I mean, you expect a return of investment, expenses. What else you may think of?
Well, it could be the margin, but I think that it's related. It's correlated to the return, right?
But why not? I mean, at the end of the day, you establish what dimension you are planning. And so you said, I'm sorry, what expenses you said,
Yeah.
or what?
No, the margin.
Margin. Okay.
Yeah.
Why not? Because based on an expense that you made, you're expecting a margin in return, isn't it? Because you
Yes.
spend, let's say you're spending $10,000, but maybe you expect $15,000, which would be $5,000 margin. correct? More or less. I mean, it depends on your business, but why not, right? So let's call this one margin. So here we will include $5,000 margin, $10,000 margin, and so on and so forth. At the end of the day, you can establish the thresholds or the dimensions that you may think of depending upon your business. I won't want you to think that I'm trying to push you to think on certain dimensions. At the end of the day, what I'm trying to tell you, these models can apply on any business that you may think of. The only thing is that I'm trying to tell you is just to bear in mind that you can apply these dimensions or these models to your business and think that you can use them depending upon how are you planning to use it. So for instance, in this case, this is a regression. What kind of regression would it be? Actually, I think it looks really optimistic, right? Let's say here, what kind of regression is this? Can be two of them, right? There are two types of regressions that this one can be which ones based on your experience?
Multinomial?
No, because
Multinomial
if it were multinomial, it will be only different lines, but in different behavior, right? So this one, it can be either polynomial due to the inflections that we have, or, I mean, binomial, no, because we have more than one inflection, right? So pretty much it can be a polynomial regression, pretty much, right? But thank you so much, Roberto. Either way, it's good to know that you have kind of a point of view because yes, first we perform a multinomial regression to understand the linear behavior for the different transactions. Nevertheless, at the end of the day, we perform a polynomial regression to understand how a multinomial regression that we have chosen would behave over periods, right? So this one is a polynomial regression, right? Which means that it has how many inflections it has. How many inflections it has? Do you remember?
Two?
It has three. Why three? Well, first it goes up. Afterward, what else? It goes down a little bit, right? Or it remains steady, right? And afterward, it goes up. So what is it doing here? So that's exactly what I want you to bear in mind, that we need to understand that there's a distance function between two different factors in our, or let's divide it into dots, right? It can be one dot here, right? Another dot here, another dot here, another dot maybe right here, another dot right here, and so on and so forth, right? So in each and one of the dots, if you want to turn it into something linear, it's something like this, right? So there's a distance between one dot and the other that can be translated into something linear. That's something I want to let you to bear in mind. So in here would be something like 10,000, 10, comma. Actually, the yellow is too boring. Okay, let me use an example. Here would be X would be 10, and the Y would be something like, let's say 2.5 maybe, 2.5. So this would be the second dot, right? Something like that. The third dot would be something like 15, comma, and what else? What would be the y-axis? 5 maybe, right? Because if we bear in mind that the X is this one and the Y is this one, so I mean, perhaps something closer to that. It's quite, just to give you an example that between this and this, there's a distance, right? So in order to calculate the distance, it's something that we use we use three different formulas to calculate the distance between two dots. The first one would be the Euclidean, which is nothing but X minus Y squared, right? And first exponential 2 and squared for that. So that's a distance. How we calculate this distance, which is nothing but a triangle. If you visualize this, let me visualize this. This would be nothing but a triangle, right? Which would be this distance. Let me change the color. So it's a triangle. That's why we use that calculation. Do you remember how to calculate the hypotenuse of a triangle? Do you remember? B squared is nothing but a squared plus c squared. Do you remember that calculation? It's something that is basic for secondary school. Here is nothing but the same. So we are calculating the hypotenuse of every single step in our line, right? That's exactly what we are doing. Okay. So we can use either Euclidean or Manhattan or Minkowski, right? However, the most common is the Euclidean distance, which is nothing but a squared, or the hypotenuse squared is nothing but the one of the cathets, which is a squared plus b squared, is nothing but the triangle distance of this, right? A squared plus b squared is nothing but the hypotenuse squared. Correct? Crystal clear? Do you remember that? Okay. Okay. This is nothing but a triangle. A and B is equal to HC. I'm sorry. I need to get back just a moment. And,
Recording in progress.
So returning back to this, we mentioned, well, so when we are talking about the Euclidean distance, it's nothing but the combination between x and y to understand what's the kind of hypotenuse distance between two dots, right? And it relies, as for instance, we can see here, actually, this is not quite accurate. So the K ratio is nothing but the distance between two dots. So in this case, we have H and we have K ratio, which is the distance between two dots. In order to bear in mind, again, that this is nothing but a triangle, right? This is hypotenuse. We have here the two components for that particular triangle, and we can understand this is nothing but the distance between 2 points, which would be x1 and x2, y1 and y2, right? Which is something that we have been managing. And to understand that is nothing but the distance between 2 points. However, what if we had more than one line, right? It would be the sum between xn plus yn, right? And it would be the sequence, nothing but a long distance, so it would be nothing but the sum of all of them. In order to understand that, that would be the total, right? So when we use the nearest neighbors, this would be kind of the equivalence. Actually, it must have a video around that. I'm not sure whether it has. No, it does not have a video. It's only screenshot. So as you can see here, we have two groups, right? Actually, three. We have the groups of A, the group of C, and groups of O. Taking into account that there are three groups, this is pretty straightforward. I would like to have one volunteer to let me know what would be the groups that you can see here. It's pretty straightforward, very easy to identify. Which are the groups that you can identify here?
There are three groups.
Three groups, beautiful. Which ones?
A, C, and O.
There you go. Amazing. How many items does A have?
8.
8.
There you go. How many items does O have?
7.
7.
7. And how many items does C have?
1.
1. Beautiful. And based on this image, What would you think that would be the differentiator to create the groups? I mean, it's pretty straightforward, but I want you to analyze it. What would be the difference between A, C, and O? Why do you think that those are different groups?
Depends on the value of X.
And what else? X and?
Well, I see it very similar in Y, but maybe.
There you go, beautiful. Exactly. Between the combination and X and Y is actually the difference between the two groups, right? Which, because here, let me see what I can write in here. Maybe shapes. There you go. For instance, we can say that this is one group, right? Crystal clear, isn't it? What do you think that they have in common? I'll help you with that. What if we create the circle and we create another two lines, just two lines, or maybe more, right? Let me include another line here. Okay, in order to create the groups, we use something called centroid. Centroid. What we mean about centroid is nothing but an equidistant point out of the entire data set, right? For instance, here we have one centroid, which would be something like this, right? That kind of that middle point out of our entire data, out of our entire data. So this one would be the centroid. So in other words, we can say, okay, guess what? The A's are nothing but all those points that are closer one to each other, and the middle point is this little O here. Okay, that sounds good. I mean, in this case, it's kind of a straightforward circle. However, this one, the C is closer to the A or to the O? What do you think? Closer to the A or to the O? Based on what I can see, is closer to neither one nor the other. That's why, as per not being neither closer to one nor the other, it's a separate group. It's a separate group, right? That's why we can think of that it can be a separate group out of actually field. Where's that field? Okay, there you go. Right, let's imagine that we have a C here, no field, there should be no field, there you go. The C is another group, and the O can be another group. How come? Well, in this case, let's imagine, right? Imagine that you are creating another circle here, right? That is grouping the or oval, any oval, that is kind of grouping those, right? That's why, I mean, what if you wanted to create two groups? It can happen, right? It can happen. What if you want to create two groups? Maybe it would be something like this, right? So that's why you need to bear in mind how many groups you want to create. Do you remember that last time we classified the shapes based on different kind of characteristics, right? Or different skills. Do you remember last class how we classified the shapes that we created?
And colors.
Colors. Beautiful. We classified them based on colors. What other classification we used?
Shapes.
Shapes. The last class we used either colors or shapes. What if we had something different? Like this time around. We don't have colors. We don't have shapes. We also have letters, isn't it? Because we have C, O, and A, right? So that's why here we have decided to create a third group out of the shapes. Because why? Because that's the nature of my transactions. This time around, I really want three groups. It's up to you how many groups you are planning to create. That's why I wanted to have these kind of shapes, just to let you know that, well, depending upon your business, what if you have What if each one of these shapes, what if one of these shapes is a transaction, right? A transaction, rather than being a circle, a O, or whatever. What if it were a transaction? Can you say that each one of these transactions belong to a particular customer? We can do that. What if we say that each one of these transactions belong to a product? It can be that one as well. What if we say that each one of these transactions belong to a cost center? What if A is one cost center, C is one cost center, and O is a different cost center? It can happen as well, right? So that's why I want you to bear in mind that the classifications of your transactions is something totally up to you. That's why it is called KNN. So K stands for any number, and N means nearest neighbors. So why do we relate to nearest neighbors? Okay, let me go there. So nearest neighbors stands for something like this. Let me clear this out.